Hi, I'm Braden Barbary, and this is my Lab 4 on oscillations. So, the purpose of the lab was to observe the oscillations of an object caused by a spring and gravity. Tracker and GlowScript were both used. The object was the system, and the spring and gravity were the surroundings. The experiment tested the energy principle and it was found that the principle held true. So, the energy principle states that the change in energy of the system equals the work done by the surroundings plus the change in heat. And for this experiment, the work done by the surroundings and the change in heat were both zero, so the change in energy of the system should be zero. And Newton's second law states that the net force equals all the forces added together. And in this lab, we use the spring force, which is this equation here, and the force of gravity given by this equation here. So, for testing, tracker was used to observe an object's position relative to the time. Individual points were placed at the center of the object for every frame to track the movement. And here is the video of the tracker going and the spring with the object at the end oscillating. For the coding, the track data was compared with a simulation of the object's position relative to the time, and using the GlowScript code, the precise locations of where the object should be were found. So, the main parts of the code are the ball's mass, which was a given value, the ball's initial position, which was found by the first tracker point, and the ball's velocity, which is zero because at the start of the tracking, the person was holding the object still. Here's the constant gravity, the spring constant which was given, and the relaxed length of the spring which was given. Here, this is finding the change in spring length. Some more important parts of the code are the kinetic energy, which is given by the formula 1/2 mass times velocity squared, the potential energy of the gravity and spring, which were shown earlier, and all these energies add up to give the total energy. The gravitational force of gravity, which is given by negative mass times the gravitational constant, and the spring force, and both the spring force and gravitational force are added together to get the total net force. And here is Newton's second law, which is velocity update, which is given by the velocity plus net force over mass times delta t, and then the position update, which is given by the position plus average velocity times delta t. The final part of the code is the length and direction of the spring, and then all the updated energies. And here's the video given by the GlowScript code. The red ball is the observed data from tracker, and then the blue ball is the model given by GlowScript. And here's some data given from the GlowScript code. This first one here is the X position, with the blue line being the model and then the red line being the experimental. And here's the Y position, with the same blue line being the model and red being the experimental. They are similar, but some differences in the experiment and model lines are caused by human errors and outside forces that were not accounted for in the code. And here is another piece of data that was given. And the most important part about this is this orange line here that stays on zero, and that is the change in energy. This is important because it means the energy principle is satisfied because the change in energy is zero while the object is oscillating. And this is caused by there being no outside forces acting on the object that would change the energy. Here, I found the oscillation periods for the X position and Y position. The period of oscillation for the X position is given by 3.134 seconds minus 1.519 seconds to get 1.615 seconds, and these are this low point here and minus this low point here. And then for the Y position, it's 2.184 seconds minus 0.665 seconds to get 1.519 seconds, and that is this point here minus this point here. Now, these differences in these numbers are most likely different due to human error. They should be the same because of the formula. Period of oscillation equals 2 pi, the square root of mass over the spring stiffness. And the stiffness and mass would be the same for both the x and the y.